Hi, I'm Jeshlyn C from 11 IPA-B. Today I will show you how to make Newton's cradle and show you how it works. A typical Newton's cradle consists of a series of identically sized metal balls suspended in a metal frame so that they are just touching each other at rest. Each ball is attached to the frame by two wires of equal length angled away from each other. This restricts the pendulum's movements to the same plane. But here, instead of using metal balls, metal frame, and wires, I used marbles, cardboard and chopstick for the frame, and string. Marbles are for the swinging mass, cardboard and chopsticks are for the structural use, and strings are used to allow the marbles to hang vertically from the chopsticks and swing. These are the materials and tools you need to make a Newton's cradle. 5 marbles, 1 meter of string, 2 pieces of 10 x 12 cm cardboard, 2 pieces of 4 x 15 cm cardboard, 2 chopsticks, cutter, scissor, hot glue gun, super glue, and ruler. First, cut 2 pieces of 10 x 12 cm cardboard to the size shown and make holes using chopstick in the marked area. Cut 2 pieces of 4 x 15 cm cardboard to the size shown. Cut 2 chopsticks to 11 cm long. Assemble the cardboards and chopsticks to make the frame. Cut the strings into 5 equal pieces approximately 20 cm long. Hot glue the marble to the center of one of the string. Repeat to end up with 5 separate marbles, each glued to the center of a string. Make 5 marks along 2 chopsticks every 1.5 cm. Make sure the marks are centered on the sticks. Glue the end of the strings to the chopsticks at each mark using super glue. The marbles must line up both horizontally and when viewed from the top. So this is how Newton's cradle works. Newton's cradle is a device that demonstrates conservation of momentum and energy using a series of swinging spheres. When one sphere at the end is lifted and released, it strikes the stationary spheres, transmitting a force through the stationary spheres that pushes the last sphere upward. The last sphere swings back and strikes the still nearly stationary spheres, repeating the effect in opposite direction. Newton's cradle aptly demonstrates the principle of the conservation of momentum. This principle states that when two objects collide, the total momentum of the objects before the collision is equal to the total momentum of the objects after the collision. In other words, when the first ball of Newton's cradle collides with the second, the first ball stops, but its momentum is not lost, just transferred to the second ball, then third ball, then the fourth, until it reaches the very last ball. You witness this conservation of momentum as the last ball swings into the air with nearly the same momentum as the first ball. Thus, if 2 balls are lifted into the air on one end of the device and released, then 2 balls on the opposite end will swing in response. This continuous clicking is also proof of Newton's law of the conservation of energy, which states that energy cannot be created or destroyed, but that it can change forms. Newton's cradle demonstrates this last part of the law quite well, as it converts the potential energy of one ball into kinetic energy that is transferred down the line of balls and ultimately results in the upward swinging of the ball. The most common application is as a desktop executive toy. An executive toy is a novelty item typically placed on the desk of a corporate executive or other office worker. They have no work-related function, but are often intended to provide or pleasure, relieve stress, or inspire creativity. Another use is as an educational physics demonstration as an example of conservation of momentum and conservation of energy. A similar principle, the propagation of waves in solids, was used in the Konstantinesco synchronization gear system for propeller or gun synchronizers on early fighter aircraft. Thank you for watching.